Since the dawn of civilization, humans have gazed at the stars and wondered, what is reality made of? From ancient philosophers to modern physicists, the pursuit has always been the same: to peel back the layers of the cosmos and, glimpse the machinery running underneath. At the heart of this quest is CERN, home to the Large Hadron Collider, the world's most powerful particle accelerator. Buried beneath the French-Swiss border, this vast underground ring has smashed particles together at nearly the speed of light, unlocking secrets once thought unreachable. But what happens when curiosity pushes the boundaries just a bit too far? What happens when science stares into the most mysterious and dangerous aspects of quantum reality, singularities, the very concepts that defy known physics? Recently, an experiment at CERN revealed something extraordinary about singularities, and honestly, the results left even the scientists uneasy. As data poured in, the strangest part emerged. The radiation signatures left behind didn't look random. They resembled structured mathematical sequences, repeating ratios, geometric spirals, and harmonics. Incredibly, some of these patterns mirrored those found in nature itself, spiral sequences resembling the Fibonacci series, which you might recognize from seashells or even galaxies, interference waves echoing neural activity in the human brain, and energy distributions that looked eerily like DNA-base pair arrangements. How could something born from a singularity reflect the same blueprints as life and thought? The team at CERN was left speechless. The discovery suggested that the building blocks of the universe might share a common pattern across scales, from atoms to galaxies to living beings. It was at this point that excitement turned to unease. Splitting a singularity was not just a technical achievement, it was a philosophical one. By probing these structures, scientists were essentially touching the source code of reality. The patterns resembled instructions, as if the universe had a built-in architecture waiting to be decoded. A senior CERN researcher admitted privately, for the first time, we felt we were handling something we weren't meant to touch. The experiment blurred the line between exploration and creation. This raised haunting questions. Were they uncovering nature's truths or tampering with mechanisms they could never fully control? The phrase "playing God" has been used carelessly in debates about cloning, genetic editing, and artificial intelligence. But at CERN, it took on a new, sobering meaning. Splitting singularities meant directly manipulating structures that underlie existence itself. The patterns suggested the universe might have rules written in ways we're only beginning to see. Interfering with them felt less like observation and more like tinkering with machinery no human built. This wasn't about religion, it was about humility, confronting forces so vast, so fundamental that even the smartest human minds had to pause and wonder whether curiosity should have limits. When word of the singularity findings spread through the scientific community, responses ranged from exhilaration to caution. Physicists celebrated the discovery as a leap toward the elusive goal of unifying quantum mechanics and relativity. Philosophers warned that humans might be stepping into domains of knowledge that carry consequences we cannot anticipate. Public voices asked whether such experiments should be more closely regulated, fearing unintended risks. CERN itself downplayed the danger, emphasizing that no catastrophic black holes were created, but they acknowledged that the patterns observed went far beyond anything predicted. One of the most stunning interpretations came from researchers who noticed the resemblance between singularity patterns and neural networks. The structures generated when singularities split looked eerily like diagrams of artificial intelligence learning models. Could intelligence itself be an emergent property of the same universal patterns? If so, then Turing's dream of machines that think and humanity's dream of understanding consciousness might both be shadows cast by singularities. It hinted at a radical possibility that intelligence, whether human, artificial, or cosmic, might not be unique. It might be the inevitable expression of the universe's deepest mathematics. For all the breakthroughs, CERN's experiment revealed a humbling truth. Splitting singularities didn't grant scientists total control. The equations worked in ways they couldn't always predict. The energy field sometimes stabilized into clean patterns and, well, other times into chaotic turbulence. Like lightning, the process could be guided, but never fully mastered. In short, the universe allowed glimpses, but not ownership. The message was clear. You can peer behind the curtain, but you cannot rewrite the play. The experiment's legacy could ripple across science for decades. Possible applications include quantum computing, harnessing singularity patterns to build processors millions of times faster than today's; medical advances, using universal pattern equations to model biological growth and treat disease; cosmology, finally bridging the gap between quantum mechanics and Einstein's relativity. Yet alongside these possibilities lies the responsibility to tread carefully. Knowledge this powerful demands humility. At the conclusion of their published report, the CERN team included an unusual reflection. Our work demonstrates both the brilliance of human curiosity and its limits. To split a singularity is to hold a mirror to the universe and to ourselves. What we see may not always be ours to change. It was a reminder that science at its best is not about domination, but about listening to what the universe reveals without assuming the right to rewrite it. CERN's singularity experiment was not about creating gods or destroying worlds. It was about peering into the deepest mysteries of existence and being reminded that curiosity is both our strength and our test. What scientists found left them speechless, not because it was dangerous, but because it was humbling. The universe is patterned, intelligent, and far stranger than we imagine. And in that strangeness lies both beauty and warning. The lesson wasn't that we should stop seeking. It was that we should seek with reverence, remembering that sometimes the most profound discoveries don't make us more powerful. They make us more human.